All right, welcome back, Algebra 2. Let's continue talking about this synthetic division uh, new technique. So we went ahead and we did a few examples with it. So let's talk about the pros and cons, just like we did with long division. So maybe, hopefully you agree with these pros, maybe you don't, and that's okay. Um, but I think it really is faster and more efficient, right? Because you don't have to do as much stuff with the variables. You're only dealing with the coefficients and dealing with operations with those coefficients. You're kind of not having to worry about the variables at the same time. So I think that's really helpful, especially for those of us that have a little bit of a hard time with the variables. Okay. Now the cons is that at first I think it definitely is really difficult. And oh, I can't draw. I can't underline for some reason. There we go. I think especially at first, because you're just like, I've never seen this before. When do I multiply? When do I add, etc. And that's okay if you're still kind of having issues with, when do I do this? When do I do that? We're going to do a few more examples with it, okay? And the biggest kicker with synthetic division is that it only works when our divisor is linear. If you noticed in the two examples we did, let's go back and look. In the two examples we did, look at our divisor. Our divisor here was x minus 2. Our divisor here was x plus 3. It doesn't work when we do a divisor that is quadratic, cubic, quartic, quintic, etc. when we keep going up, okay? It's only gonna work when it's linear. And please do me a favor and like highlight this statement, circle it, write it in all caps, whatever you need to do to kind of make this very clear to you every time you refer back to your notes. Because if I ask you to divide something by, say, like x squared plus 2x minus 7, you have no choice but to do long division. You just have to do long division, okay? But the cool thing about synthetic division is that because we can only divide by linear factors, so by linear I mean stuff that looks like x minus c, is that really does help us to factor. Like if I divided by this and I found out that this was a factor, it's not as nice and as convenient and as informative as if I find out that a linear polynomial, sorry, a linear polynomial is a factor. Because when we factor, think about quadratics, when we factored that kind of stuff, we had the product of linear terms like x plus 7, x minus 2, and that's our goal, to make it look like that. So with synthetic division, since we're dividing by stuff that looks like each of these, then we're working towards that goal. Okay, so that's kind of the benefits and the drawbacks of synthetic division, okay? So synthetic division can help us factor a polynomial, especially when we know one of the factors or one of the zeros, okay? Remember zeros, we talked about this term. It's synonymous, or it's the same thing as x-intercepts. And it's also the same thing as when we say roots, okay? Make sure that you remember that these three terms are almost the same thing, okay? So here's a little theorem that we kind of want to keep in the back of our heads that is going to help us with what we're doing right now, right? It's called the factor theorem, okay? If x minus c is a factor of a polynomial f of x, then f of c is equal to 0. So the question I have for you, and go ahead and pause after I ask this question, is what does this mean? What does f of c equals 0 mean? Why do we care about when f of c equals 0? Okay, think about it for a few seconds. All right, we're plugging something into our function, and the result is that we get 0. Well, then that means that c is an x-intercept. Okay, or otherwise known as a 0. Okay, so you're probably like, Mr. G, why do I care about that? Well, the reason why you care about that is because now, when they give us a factor, and you kind of already know this, right? Whenever we get x plus 7, x minus 2, from factoring a quadratic function, and I ask you to find the x-intercepts, you usually can immediately tell me, oh, it's a -7 and +2, right? So the reason why we care about that is now what I can do is if I know an x-intercept or I know a factor, then I can use synthetic division very nicely to factor a function and then to find the remaining x-intercepts, okay? Let's see how that works. Example 3. Let's factor this function, x cubed minus 10x squared plus 19x plus 30, given that x minus 6 is a factor of f of x, okay? So what does it mean for it to be a factor? Well, that means that when I take x minus 6 and multiply it by a bunch of garbage, so a bunch of polynomial goop stuff, when I multiply it by another polynomial, I'm going to get x cubed minus 10x squared plus 19x plus 30. Okay, let's say that I wanted to solve for this. Well, it's being multiplied by x minus 6, so what's your first instinct? Let's say, like, if I had 6x equals 10, what do you do to solve for x? You divide by 6. So it's the same thing here. What do I do to solve for this stuff that I don't know, this polynomial? Well, let's divide by x minus 6. Oh, and we already know how to divide polynomials. We just learned synthetic division. So let's do it. Okay. So pretty much this problem is asking us to divide x cubed minus 10x squared plus 19x plus 30. Okay, that's not all we're gonna do, but that's the first thing we should do. So first thing we need to do is divide x cubed minus 10x squared plus 19x plus 30 by x minus 6. So let's do that using synthetic division. Okay, let's copy down those coefficients. Do we need a placeholder? No. So 1, negative 10, 19, 30. Do our little shelf. Opposite of our constant terms, so positive 6, and then our horizontal line for our answers down here. Very first step, hopefully you didn't forget, bring down the 1, bring down the leading coefficient. Okay, I'm not going to do the arrows anymore, but you can continue to do the arrows that I used above to kind of help you keep tracking where each of everything is going, okay? So 6 times 1, that's 6. Negative 10 plus 6, that's negative 4. 6 times negative 4, that's negative 24. 19 minus 24, ooh, that is going to be negative 5. 6 times negative 5, that's negative 30. 30 plus negative 30, that's a beautiful, fabulous 0. Okay, remember what our coefficient or what our variables are. This is x cubed, x squared, x constant. So then it reduces by 1 for our quotient, x squared, x constant, and then remainder. And there's no remainder. Hooray! So we know for a fact when you get a remainder of 0, then you know for a fact that x minus 6 goes into this evenly. And we already knew that because we knew x minus 6 is a factor. When we see that, we know that it goes into it evenly. Whenever I say 12 is a factor of 24, that means we know 12 can go into 24 evenly, right? So then we know then that if we're factoring this, remember the whole point is that we're factoring this. So x cubed, let me get rid of that equal sign because I kind of jumped the gun. X cubed minus 10x squared plus 19x plus 30. We now know that we can rewrite that as x minus 6 times, we found out what that mystery polynomial is, that garbage, that stuff. It's this right here. It's the result of our synthetic division. X squared minus 4x minus 5. And if you're not convinced, multiply that through and you'll see you'll get the same thing over here, okay? Now we factored it. We factored it a little bit in. We just need to keep going or check to see if we can keep going. Can I factor this? And let's do it up here just so we have more space. So x minus 6 times x squared minus 4x minus 5. Can I factor x squared minus 4x minus 5? Well, this is a 4.3/4.4 problem, so you should remember, right? Are there any factors of negative 5 that add up to negative 4? Why, yes, those two numbers are negative 5 and positive 1. So this is equal to x minus 6 x minus 5, x plus 1. Boom, bam. We have factored the cubic function that we started with. Okay, an otherwise unfactorable cubic function, because if we look at this, we would not be able to factor by grouping, because whatever we factor out from the first one, it would not be the same as the second one. Okay, because notice that when we factor out the x squared, we're left with x minus 10. Here, there's no way I can get x minus 10. Okay, so cool. We have a new quote unquote factoring method. The only crutch is that we knew one of the factors, okay? And most oftentimes you're gonna know one of the factors. You're gonna be able to either be given that information or you can graph it and find one of them, okay? One last example to hit it home, you guys, okay? One more. And this one's worded a little differently. So let's see how that changes our process. Find all the zeros of f of x equals 3x cubed minus 2x squared minus 61x minus 20, given that one of the zeros is negative 4. Okay, remember from our factor theorem, if we have a zero, if c is a 0, then that means, if and only if, so it's double implication, that can go either way. If c is a 0, then we know that x minus c is a factor. So let's replace c with our, in this case, negative 4. Okay, so negative 4 is a 0, so that means that x plus 4 is a factor. So then what am I going to do? I'm going to start by dividing 3x cubed minus 2x squared minus 61x minus 20, dividing that by x plus 4. Oh, and we know how to do that because we know how to do synthetic division now. So let's start with that, okay? Do our coefficients. So let's go ahead and write them out. We have 3, negative 2, negative 61, and negative 20. We put our little shelf down. Okay, opposite of the constant term, so negative 4. Or another way you can think about it is the 0. So our 0 was negative 4, so that's going to be what goes on the shelf. Okay, and draw our horizontal line to show that our answer is down here. Very first step, bring down the leading coefficient, so 3. Negative 4 times 3, that's negative 12. Negative 12 plus negative 2, that's negative 14. Negative 4 times negative 14, that is positive 56. Okay, so then 56, negative 61 plus 56, that is going to be 5. Sorry, I don't know why I'm struggling with that. Negative 5. Negative 4 times negative 5, that's positive 20. And we get a beautiful, beautiful remainder of 0. Okay, and that's what you need if you know it's a factor. If they tell you it's a 0 or it's a factor, if you did not get 0 here, then you need to check your work again because something kind of went wrong. Okay, so now remember, x cubed, x squared, x constant, because that's what we started with. That's this right here. And so then we end up with x squared, x constant, remainder. So then what do we get? We know that this, I can erase this right here. We know that this is equal to x plus 4 times 3x squared minus 14x minus 5. Okay, let's keep going. Let's keep factoring this because eventually we still need to find the zeros. So we need to find the x-intercepts, right? So we're going to factor this and then at the end set it equal to 0. Okay, we just need to factor the inside quadratic. Well, it's a quadratic where the a is not 1, so we need to do a times c. 3 times negative 5, that is going to be negative 15. What two numbers add up to, or sorry, multiply to negative 15 and add up to negative 14? Well, that will be negative 15 and positive 1. So then I separate my negative 14x into that. Okay, I get 3x squared minus 15x plus x minus 5. Factor by grouping. What can I factor out of my first two terms? That's going to be a 3x. What am I left with? X minus 5. What can I factor out of these second two? Nothing, so just a 1. X minus 5. Okay, this is my common factor that I can factor out as a GCF. So I have x plus 4, x minus 5, because that's my GCF between these two terms that are left. And then what am I left with? 3x plus 1. Perfect, that's factored form. Now to find my zeros, set equal to 0. You can cheat a little bit, you already know one of them. So we really don't have to care about that x plus 4 because we already know one of them. You can, if it makes you feel better, you can set it equal to 0 and solve for it just to be consistent, right? Subtract the 4, subtract the 4, boom. The negative 4 is one of our answers. X minus 5 equals 0, and 3x plus 1 equals 0. Add the 5 over. We get x equals 5. And then subtract 1. 3x equals negative 1. X is equal to negative 1 over 3. So those are our zeros. Very awesome. Okay, synthetic division. What do you think? Do you agree that it's a little bit simpler, a little bit more easier to manage than long division? Or are you thinking that long division is a little bit more up your alley? Okay. I want you to make that decision for yourself, okay? But I want you to wait until after you practice both long and synthetic. And then 5.6, we're going to be doing a lot of this stuff where we're factoring down polynomials to find missing zeros. And in that case, I'm going to let you decide whether you like long division or synthetic because you can go either way. Okay, they're both going to work. I hope that this sounds okay, you guys. Please, 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 in class, talk to me if you need any help. We're approaching the end of our first quote unquote semester. So if you need to get that grade up, we need to get that grade up. So come talk to me, okay? Have a great rest of your night. I will see you in class.